Okay, so in our previous class, we had studied about break even point. Okay, and we have also calculated some numericals relating to the break even quantity as well as the cost. Okay, so today, before moving on to the numerical relating to break even again, we will just summarize the concept which we have learned in break even. Okay, so to calculate break even, we should have the value for the fixed cost, and we should know the value for the selling price, which is per unit, also the variable cost per unit. Okay, so the fixed cost is nothing but the cost which remains fixed for some time period. Okay, so that is nothing but the fixed cost. Selling price is nothing but the price at which the organization will sell their commodity or the product or the services. Variable cost is nothing but the cost which increases with the volume of production. Okay, with the increase in the number of quantity or manufacturing a quantity, accordingly the cost associated with that will increase. Okay, so that is nothing but the variable cost. So variable cost are nothing but the cost which varies with the unit of production or the volume of production. Okay, so using these three components we can calculate the break even point in terms of units. Okay, so break even point is nothing but a point or a region at which the company is not making any profit nor the loss. Okay, so that is nothing but the break even point. So higher the value, higher the quantity above the, say for example, a point which is having above the break even point, so the company will be getting the profit. If it is less than the break even point, the company will be making the loss. Okay, so there are some assumptions in break even analysis. First one is, in nature there would be different overheads. Okay, the cost, different costs involved, but in calculating break even analysis we generally consider the fixed and variable cost. So there are semi variable cost. Okay, there are some overheads. Okay, so those cost parameters are not considered in calculating the break even analysis. So when we calculate break-even analysis, we assume that the company will only consider the fixed cost and variable cost into picture. For other parameters or overheads or any other like semi-variable cost components, there are different ways. Say for example, you have ratio analysis, which you have it in the financial statements. Okay, so that will give us the financial position of the organization, but for calculating break analysis you generally consider the fixed and variable cost. So that is one assumption. Then selling price of a product is assumed to be constant, so that means the selling price will be constant for a given time period, so that will be an assumption of break even. Okay, it assumes constant rate of increase in the variable cost. So this variable cost will increase or decrease, right? It keeps on fluctuating, but when we calculate break even we assume that the variable cost will be with increases with the constant rate. Okay, then it assumes no improvement in technology and labor efficiency, so we are not going to consider any technical or labor cost or efficiency productivity when we calculate break even analysis. So that is one assumption. Okay, then production and sales are synchronized. We assume that, so for each production there will be equal number of sales. Okay, so in practical situations that production and sales will not be synchronized to a larger extent. Okay, but in calculating break even analysis we assume that the production and sales are synchronized. Okay, so these are some of the assumptions. So comparison of alternative analysis. So here we calculate break analysis to compare between the alternative and suggest which is the economical alternative. okay, among the two or multiple alternatives. So break analysis can be used for comparing different alternatives that are available for producing a particular product. Okay, so here it can be used to compare different alternatives which are available for producing a particular product, and these alternative will differ in terms of cost, and it is proportionate with terms of the output. Okay, so these differ in terms of cost and are associated with them at different levels of output. So example, at lower levels of output, manual operating techniques may be profitable, but at the higher level it would be non-profitable. Okay, so that is one example which they have given. Hence, yeah, students, can you hear me? There was some technical problem.
Yes,
Yes,
sir,
sir.
we can.
Yes. Okay, thank you, thank you. Right. So when we compare the alternatives, we basically calculate the total cost at the break-even point. Okay. So at break-even point, we calculate total cost, or we compare the total cost of alternative one with that of the alternative two. Now total cost is nothing but the fixed cost plus the variable cost. So we calculate, or we take into consideration of the fixed cost of the alternative as well as the variable cost to the second project's fixed and variable cost. Okay, and depending upon the value, we suggest this particular alternative will be the economical. Okay, so here when we compare, we even consider the break even point. Okay, so this is actually a graph which shows the total cost. Okay, so you have a fixed cost, as you have a fixed cost, okay, which has been indicated here. Okay, and this is nothing but the total cost curve. Okay, so total cost of alternative one has been given like this, which is highlighted in red. Okay, and the total cost of alternative two has been given in black. So you have x-axis, which is unit of output, and y-axis as the cost. Okay, so the point which where the total cost of alternative one is equal to that of the alternative 2, that gives the break even quantity. Okay, so that is nothing but q, okay, unit of output. So break even quantity is nothing but the point at which the total cost of alternative 1 will be equal to that of the alternative 2. Okay, So when we compare the alternatives, we generally take into consideration of the total cost, and based upon the total cost of alternative 1 and 2, we arrive the break even quantity. Okay. So this is one numerical which we are going to solve now. So please take down this numerical. So here the question looks big, but the numerical is very easy. Okay. So please try to please copy down this numerical. A 50 HP motor is required to drive a pump to remove water from a tunnel. The unit will be needed for a period of 4 years. Two alternatives are under consideration. Alternative A calls for construction of a power line and purchase of electric motor at a cost of $4,900. The salvage value of the equipment after 4 years is estimated to be $700. The cost of the current for the per hour of the operation is estimated to be $2.94, and the maintenance is estimated as $420 per year. Okay. The alternative B calls for purchase of diesel engine pump set at a cost of $1,925, and it will have no salvage value at the end of 4 year period. Okay. The cost of the diesel per hour of operation is estimated at $1.47. Maintenance is estimated at $0.53 per hour operation, and the cost of wages chargeable when the engine runs is $2.8 per hour. How many hours per year the two machines have to run so that the two alternatives incur equal cost? So if the number of hours of operation is estimated at 100 hours, which alternative is more economical? Take interest rate at 10% per year. Okay, so here in this numerical, to remove water from a tunnel, okay, 50 HP motor is required, and the motor is needed for a period of 4 years. Okay, for this there are two alternatives. Okay, and the cost parameter of both of the alternatives has been given, and we need to calculate how many hours per year the two machine have to run so that it incurs equal cost. So we need to calculate what is that hours which has to be given so that the two alternatives will have equal cost. Okay, and also we need to calculate if the number of hours of operation is estimated to be 100 per hour, which alternative is more economical. So if the number of hours of operation is taken to be 100 hours, so which alternative is more economical? So that is also we have to find out. So to calculate, the interest rate has been given, that is 10% per year. Okay. So these are nothing but the data given in the numerical. Okay. So have you taken down this numerical?
Yes, sir.
Yes. Okay. So I will show the solution from the screen itself, solution to this numerical. Okay. So we will first assume that X be the number of hours each alternative is operated per year. So that means we will consider X as the parameter for which represents the number of hours each alternative is operated per year. Okay. So then we calculate the total cost of each of the alternative. So the total cost is nothing but the fixed cost and the variable cost. So here they have given a company for a call for the construction of a power line and purchase of electric motor at a total cost of 4,900. So 4,900 is nothing but the initial cost plus the salvage value of this equipment after 4 years has been given. So when we have two cost related factors, we generally take into consideration of this capitalized cost, not capitalized cost, capital recovery cost. So that is nothing but P minus F, that is 4,900 minus 700 A by P I to the power N. So N is nothing but 4 years. So we required those components or alternative for a period of 4 years plus S into I. Okay, so that is nothing but the capital recovery cost. Okay, so total cost is nothing but total cost is nothing but the sum of capital recovery cost plus the annual operating cost. So it is 4,900, that is P minus F, A by P, I comma N plus F into I, okay, plus 420, which is nothing but the cost of maintenance, okay, which is $420 per year, and also the annual cost of operation, that is 2.94, okay, per hour. So it will be 2.94 into x. So likewise, calculation for the total cost of a diesel motor will be 1925, because there is no salvage value again. So it is salvage value will be 0. So it is P into A by P, 10% for a period of 4 plus the annual operating cost, okay, into X. So substituting these two equations, okay, that is total cost of electric motor equal to total cost of diesel motor at break even point, okay, we get the value of X, that is 647 hours. Okay, so that means at if the hours of operation per year is 647, both alternative incurs the same cost. So that means at 647 hours, both alternative will have the same cost. So that is one part of the question which we need to calculate. Okay, then they have given for 100 hours of operation what will be the total cost. So substituting x as the value of x as 100, okay, in the first equation, and in the first the electric motor as well as the diesel motor equation, okay, so you will be getting the value. So depending upon the values, you will be selecting the best alternative. Okay, so this is nothing but the solution. So any difficulty here, students? So only thing is here at break even point, we assume that the total cost of alternative 1 will be equal to that of the alternative 2, and to calculate total cost we should have capital recovery cost plus the annual operating cost. Okay, so then when we equate, we find the value of x. Okay, then once we calculate the value of x, we have to take 100 hours of operation and find out which is the effective one. Okay, so substituting that x as 100 in the equation for electric motor and diesel motor, okay, we will get the total cost values. So depending upon the values, we will find out the effective alternative. Okay, select an alternative with the least total cost. So the alternative which gives the least total cost among the values, okay, so that alternative will be selected. Students, any doubt here? Students, any doubt? Am I audible?
Yes, sir. No
Yes,
doubt.
sir.
Got it.
Okay. So only thing is here in this numerical you need to know the total cost equation. Okay, so total cost, one is nothing but fixed and variable cost. If in the numerical, if they have given the fixed and variable cost, you can use that equation to calculate the total cost. But in the case when interest rate is given, right, I is given, and you have the annual operating cost value, salvage value, and the principal investment. Okay, in that case you can use the equation for total cost as the capital recovery cost plus the annual operating cost. Okay, which we have also learned in economic value of an asset, the same equation. Okay, so then we will calculate the unknown factor x. Okay, if they have asked us to calculate the number of hours of operation for each of the alternative. Okay, so at break even point, this total cost of one alternative will be equated to that of the other and calculate the value of x. Okay, then substituting value in the equation will give us the total cost for the 100 hours of operation per year. Okay, then among the two, the one which is having the less of the total cost, so that will be selected. Okay, so shall we move on to the next topic, that is risk analysis?
Yes, sir.
Yes, okay. Okay, so the next topic is nothing but the project risk and uncertainty. So this is very basic topic, or what we can say is we are not going to cover the in-depth part of risk assessment or analysis. This is very basic and just introductory topic relating to the risk and uncertainty. Okay, it just gives the introduction, in the sense it just gives the definition and what are the types. Okay, so risk is nothing but the potential for loss. Okay, so that is nothing but the risk. So when it comes to project risk, right, so the possibility that the investment project will not meet our minimum requirement for acceptability and success. Okay, so that means when we consider any of the project, we see whether the company have to invest more, okay, or the company have to invest less, or whether product or the project is meeting the requirements of the organization or not. So that is how the project risk will be calculated. Okay, and this is nothing but the assignment of probabilities to various outcome of an investment project. So you are going to analyze the probabilities based upon the outcome, as well as based upon the outcome by considering the investment. Okay, so considering the investment, you are going to see the outcomes. Okay, so that is nothing but the risk analysis. So assessed by variability in a project's net present worth. Okay, so basically we calculate net present worth here. So our task is not to try to find risk free projects. They don't exist in real life. There is no risk free project as such. The challenge is to decide what level of risk we are willing to assume, and then having decided on your risk tolerance, to understand the implication of the choice. So here in risk analysis, basically we are not going to completely reduce or completely uh, reduce the risk, or we do not find risk free project. Okay, so we try to minimize the risk and how we can take that tolerance into consideration for our operations. Okay, so that is one thing which we generally do in the organization. Okay, so there are three different tools for assessing project risk. One is nothing but sentiment and sensitivity analysis. So sensitivity analysis is nothing but a means of identifying project variables which when varied has an influence on the other. Okay, so that is nothing but sensitivity analysis. When you change one of the variable of a project or a product, how the acceptably or how the other factor will be varied. Okay, so that is nothing but sensitivity analysis. Break even analysis is nothing but the point or a region at which the company is not making any profit nor the sales. Okay, so that is nothing but break even. Scenario analysis is nothing but a process of estimating the expected value of a portfolio after a given change in the value of key factor that takes place. So scenario analysis is nothing but you will be considering the variables which has an impact on your project. Okay, so example they have given, a firm might use scenario analysis to determine the net present value of a potential investment under high and low inflation scenario. So this is nothing but the one which we have studied in previous classes. So we generally calculate net present value by considering that this is nothing, these are the cost estimate which may incur in the future. Okay, so considering the future we will be calculating the present value of it. Okay, so that is nothing but the scenario analysis considering a particular case. Okay, so this is what I have to show for this particular class. So any doubts here, students? So this is nothing but the basic introduction about the risk and uncertainty. So any doubt here?
No, sir.
No, right. So then we will stop it here. Okay. So this is what I want to discuss for the today's class. Anything which you want me to inform you?